that domain system is set up in. But that's all you really need to know. You don't. It's not going. It's a DC type thing, and until you change it from DC to something else, it's not useful. Now this leads to one of my inventions that makes possible the building of a supermagnet battery, where you just simply use a magnet and do some very simple things, and you're using the entire Gauss output of that magnet, and the magnet is acting like a sponge that's absorbing water to the Earth's background or ambient. And to the degree that it can absorb that is the degree to which the electrical level in that magnet will, the flip side of what's in the magnet can be, and you won't deplete the magnet. It would just soak up some more. When sun comes out, it just refills immediately.
I have a follow-up question. If I wrap a coil around my magnet, put a signal in it,
unless you tune that coil to the resonant frequency of the metal that's in the magnet, you're not going to get anything.
When the magnet begins to ring,
okay,
is that an indication of resonance?
Okay, this gets off into another area of building where you have overlapping wires and a whole slew of other things, and you raise the electrical field that's disturbing the magnet or whatever to a certain level, and the magnet will start ringing, and when it does ring, you best back off very shortly, because you're fixing to have an explosion.
Is the ringing an indication of resonance?
Yes. It has become resonant, and it's like the thing that Tesla built, the little matchbox thing that he put on the back of a chair up in Manhattan when his laboratory was there. And this little matchbox on the leg of a chair was shaking the windows and turning things over several city blocks away, and the police thought something, earthquake or something unusual was going on, and the only nut in the neighborhood was Tesla, so they went directly to his place, and they broke down the door to get in. They didn't bother to open it. It was open, but they broke it down, and Tesla realized what was going on, so he demolished the little resonator thing. Now that resonance you're talking about in the magnet will do, you're getting into that same situation if you're not careful. Yes?
You said that if a coil was tuned to the metal contained inside of the magnet, if you wrapped a coil around the magnet and it was tuned to the metal, then you would produce some sort of energy. Let me ask you this. If we were to wrap a wire around the smallest magnet that we could possibly get, okay, physically wrap it around, and use the smallest possible capacitor to tune that coil, commercially available, the most that we could really hope for is a resonance in the megahertz range.
Okay, let me say this. Since magnets where the domains were set with DC current, the resonant frequency of that magnet is not going to be up in the megahertz range.
It will be lower?
It'll be a lot lower.
Interesting. Okay.
Yes?
That magnetic sponge type device that you were just describing?
I hear part of what you're saying.
That you were just describing a device that, like a magnetic sponge type thing with a...
The comparison of the sponge taking out the ambient or the background, the permeability of the magnet or the magnetic material will set the level of the saturation that it can pull out of the air. It's like free energy, because what's happening is that magnet is feeding off of the ambient which is around you, which is very high. And at this point, the magnetic material, the best they have will give you about 25,000 Gauss. But 20...
I'm sorry, Don, I didn't mean to cut you off.
I can't hear you.
If we could, Don, could we save questions to the very end for you?
Will somebody please tell me what...
Save your questions.
Save the questions till the end.
Okay, or whenever you're ready, we'll let me know.
We're ready.
We'll be here.
Okay, we need something else on the setup before we can go ahead. I have those nice colored photographs, and I can't show them very well this way. Do you have the extra camera where you can do that? I don't know if I can't hear you.
Talk louder, John. He can't hear you.
He said no.
No.
He said no, he doesn't have extra camera. Okay, well this is going to create some problems, and you're probably going to need a telescope to see what's going on here. But I have a lot of real nice photographs, and I have about 6 or more devices which we're going to be talking about. The original one, which I did some time ago, which the devices which show up in previous meetings like this were a spin-off of. The actual invention was not the device which I was showing you here, because that was not patentable. It was something which already existed, which Tesla built back in the 1800s, and that was the basically what we're looking at here. This background that the Earth has, a tremendous electrical background. I developed a system where you could take out any part of that you want, and what you do, you transmit from the station that's taking it out to some remote point the electrical energy. Now, the patent office says you can't do that. Tesla says you could, and it turns out that there's black projects that the RAND Corporation is running here in the United States with black project money from the government, and there's also a similar group over in Tokyo. And what they're doing, you know, the solar panels that they try to get energy out of that's up in the air. Okay, it turns out that the electromagnetic waves that are hitting the surface of the Earth here on a bright sunny day at Houston, Texas, where I live, is equivalent to about 120 volts of electricity, the magnetic flux coming in. And the way you know that is that you use a solar device, and you may, well, actually you can use your Gauss meter. If you point it at the sun and sit it on the ground, well, you'll get a reading on it, and when you move it away from pointing at the sun, you won't have that. So the amount of Gauss that you get will transmit at Houston, Texas, at my home on a bright sunny day to say about 150 volts of magnetic flux, equivalent of 150 volts of electricity. Now, if you go up into where the solar panels are orbiting the Earth, it's about 5 times that amount, the incoming magnetic flux from the sun. Now, it turns out that we were talking about the electrical charge that's on the Earth. It is considerably greater than what's coming in from the sun. The sun is in addition to that. So ambient is what the Earth has in its system, like your blood is in your system. And something that's other than ambient is what you're measuring when you're measuring incoming magnetic waves. Now, the black projects that I was talking about, the RAND Corporation, they belong to the CIA and some other people, and they're used particularly for working projects that the government doesn't want you to know about. So at that point, they have satellites that orbit the Earth that have these solar panels on them, and they transmit the energy from the solar panels down to an Earth station using in the gigahertz frequency range, and they lose almost no the electricity they're picking up on their solar panels there is coming through down on the ground at a receiving station exactly as it was on the solar panels, without any measurable loss. So I did not know about this when I first started working and submitting the application on that particular patent, and but they kept kicking it back to me, telling me that you can't do this and you can't do that, and the Earth's magnetic and electrical field is minute, and what you're saying is all wrong, and you're going in the wrong direction. But what they didn't know is that I had been through practically every major university library in the United States, including the Library of Congress and a whole slew of others, and I have 3 universities that are real close to me that have between them probably 20 million volumes. And So I have access to an awful lot of information, and the people in the patent office were not aware of that at all, of course, and they were not interested in it at all. Now, the space and well, there's here in Denver, Colorado, or at Boulder rather, there's a part of the government which monitors the exact same things which I'm saying exist, and they have published many books, large books with great detailed information that back up every word of what I said. But of course the patent office, they don't consider that authoritative. And I had professional engineers with degrees that, and qualifications that were beyond question, that had maybe 50 or more years of experience in all levels of electronics and electrical engineering, and I had them take my device and this particular one that I'm talking about now and check it out, and they wrote a recommendation letter that it was exactly as presented, that there was nothing, you know, that there was nothing that would disqualify it from doing exactly what I said it would do. And several of these with all of their curriculum vitae, which, you know, say one of them had enough things behind him, books written, he recognized all over the world as a legal reference whenever they had a legal problem in regard to power companies or anything related to the electrical industry. This particular fellow was a legal specialist with an electrical engineering degree, and with about more than 40 years experience. And the patent office considered that they weren't qualified. So there were two of them that I did like that. And when they responded, well, your references are no good, you know, and the sources you're quoting are no good. Yes?
Maybe you can pass the pictures around as you're talking about each device.
I didn't understand.
As you're talking about each device, you could pass the pictures around.
Yeah, I'm going to be showing you some of them. The particular device I'm talking about is in
We have
the...
about 20, 30 minutes left.
Okay, we better hurry because I've got some other things that are a lot more fascinating than what we've been talking about.
Well, let's
Well,
get
let's
to
get
it.
to the best one and cover it in detail.
Yeah, I think we're all here.
Okay, how about propulsion system slash star system? Propulsion slash star system.
Sounds good. Good choice.
Is that okay?
Okay, we're ready.
Okay, we've been talking about what electrons can do and what magnetic fields and a whole slew of other things. We've been talking about block walls, and which one of the side inventions that came out of this, which I filed on, is the star system propulsion deal. And basically what it amounts to is that if you have something that is highly diamagnetic, you have diamagnetic and paramagnetic. Diamagnetic is against or not compatible with a magnetic field, and paramagnetic is the degree to which it's compatible with a magnetic field. Now, as it turns out, there are tremendous differences in the position of the different elements in regard to diamagnetic. Some of them are some things that you think are antimagnetic. Well, there are things which are more than 10,000 times greater repulsive effect. So if we take the Roswell incident and the metal samples that were analyzed out of that, we get a clue as to what those things are that are extremely anti-magnetic. And we take some of this material and we build a dome-shaped thing like a bowl, maybe so far across, whatever will fit inside the bubbles that are on the flying saucer pictures that you see. And we take the top half of it, and the bottom half is basically missing. But down here where the bottom half is, there's something there that weighs parts of just maybe 2 or 3 ounces. And it creates such an intense magnetic field that this thing will lift tens of thousands of times the weight of whatever it's hooked to. It takes very little electrical force to do this, but you can approach the speed of light with the object or platform that thing is attached to. So this is still very classified, and I'm going to tell you just enough about it that you know that it exists and you'll be watching for it. But what it amounts to is that any object, like for example in the railgun, where they fire the metal projectile, they have a big capacitor bank and they build up this tremendous energy level and they turn it loose all at once, and this piece of metal goes out trying to approach the speed of light. Actually what this is, it's similar in action to the railgun, except that the platform is hooked to it and it can't get away, but it's going to go wherever that intense magnetic field points it. So you can build any kind of object. It doesn't, the shape of the object is immaterial, and attach these things to it and you've got a flying saucer or some equivalent of it. So by knowing what the metals were that were analyzed from the Roswell crash and a few other things, I'm able to build the propulsion system that is most likely. That's the simplest approach to it. You don't need element 115 or any kind of exotic thing which the government would like for you to think you need. It's relatively simple. Even the most uninitiated person probably could figure it out. So I always look for simple answers. I never look, anything I approach, my ego doesn't tell me I have to have a terribly complicated thing to solve before I'll solve it. I've found that the most valuable things frequently are the closest to nature, and that in most cases they're the most simple things. So I always start looking for a simple answer first, and I'll leave the complicated answers to people that have to explain what I'm doing.
What kind of metal we need to use, Don?
Sir?
What kind of metal do we need to use?
I'm going to leave that open, and if you've got
Where do we look for it then?
Okay, if you go to the internet and look on Art Bell under crash debris. Do what? How many people here have actually seen that and probably know what I'm talking about?
What?
Okay, well see there's we've got probably half a dozen or more here that actually know what I'm talking about.
So
Art Bell on the internet.
So Don, if it's on the internet, then why would you not be able to say that?
Why would I not be able to see it? Because
Say that.
I don't want to encourage more people than, I don't want any more competition than necessary. I've already filed on it, so as far as competition goes, it's partially taken care of, but that doesn't mean I wouldn't have to spend millions of dollars in legal battles to defend it. Yes?
Well, I have two questions for you.
Okay.
One, it sounds like from the beginning of your talk here that your main goal is to make a better place for us to live here on Earth. Is that a true statement?
Well, that's hopefully it, but if the Earth gets intolerable, you may have to find a way to get somewhere else.
The second part of that question is then to best get that accomplished, is it better to keep all this to yourself and try to get rich off the thing, or is it better to try to distribute
well,
some
if I was
so that people can use it?
major oil company or someone that's related to things as they are today, I would rather keep quiet, and the problem is that they're ignoring the fact that they're going to die along with the rest of the people.
The other philosophy is if you tell it to all of us, we'll spread the word and they can't kill us all.
Well, the ones that will survive will be the ones that like coconuts and climb in the trees, and they'll have to start the whole mess over again, I guess. It makes you wonder how many times the civilization has got this far before and wiped themselves out without being aware of the fact that they were doing it. Let me...
Don, can we see your prototypes and take measurements?
Probably not. I've got beautiful prototypes on all these things. Yes?
Can we get back to one of the energy converters?
Plans to build them?
And just talk.
Well, based on what I've just told you, you don't have to, I've actually told you enough that you can do it. The hard part I've given you, so you already know what you need to know. Yes.
I think this is a safe question to ask, but the red wires that you wrap around the coil, is that part of a resonating?
Well, the magnetic flux lines that are moving about are intercept or cut the wires,
Yeah.
and that causes a induction type thing to set up, and that's how you get the energy out of the magnetic field.
That would be the L1, and you also have an L2.
Well, that's the reason you wind coils and intercept them with magnetic, pulsating magnetic fields, induction type things. Okay, we better go on to something else because we still haven't talked about. Sir?
You've already given us enough information for us to become energy independent.
Okay, why don't we do that? Why don't we do that right now?
Yeah.
Okay, okay. How many minutes do we have?
You got enough to do this.
Huh? 30
You
minutes?
have enough to do it.
30 minutes or however long?
However long.
However long, okay.
Have our attention.
Real John? John?
Yes, sir.
You forgot to mention we have a how-to video coming out next week.
I couldn't quite hear you.
We have a how-to video coming out next week.
Okay,
A how-to video is coming up.
okay.
Explain here and Bertie down
Okay, a lot of these photographs are going to be too small for you to see, and what I'm going to do is try to sit them up here and let you see what these things look like when they're up and running. Okay. Can you see that?
Yeah. John?
I know it's unfair to ask you that question, but I don't have any other way to
Would you comment again on
do
He
it.
was want to know that the CIA talk about the
Well, we'll talk about that after the meeting.
yeah, because he wanted to.
Okay.
We talk. Okay. Well, somebody was wondering if I've been interfered with by the government authorities or any of the agencies and this and that. That's a little bit. We don't have time to talk about that right now. Besides,
How big a hole are you putting in that plate where it intersects
Sir?
the magnet? How big a hole are you putting in the plate that bypasses the magnet?
okay, it has to be somewhat less than the diameter of the magnets.
Well, that's one How far apart are they?
They're about 3/4 of an inch. These are 100 Gauss each. Composite magnetic field is 200 Gauss, which if you take that 1 Gauss equal 100,000 volts there, the potential would be that, but you're never going to be able to do it because the device itself would go up in smoke with very little manipulation. Okay, what you're looking at now is one side of a working device. It's 13.5 inches high, and it's got 8 separate systems here. Each one of these has the counterpart on the other side on the board, which I'll show you in a minute. This coil, you can see where it goes through the hole there, but it goes through and comes out on the back side of the board and continues on the counterpart of the one that's on top of it. And what you're doing there, the composite magnetic field, as long as the magnets are interacting, you've got a composite electric field which is equal to the sum of whatever is going on. So these magnets that I have, even when they're far apart, you wouldn't be able to hold them with your arm. They'll come together like a shotgun. And if your finger happens to be in the wrong place, you have no finger left.
What size are they?
But these are not the most powerful magnets that are out there. In super magnets, you have category like category 1 through 5. These are category 4. There are magnets which are much greater. They go up to 25,000 Gauss. And you can translate that 25,000 Gauss of magnetic flux into electricity, and you can see what the potential might be in regard to those particular magnets. It's how much?
Years or age, 13,000 gallons, the magnets?
Well, mine are actually down on the low. They're in the category 4,
Okay.
which I don't know exactly where the category break takes place, but mine are in category 4, and they're considered to be by most people they're considered to be the top. But from a laboratory system, magnets that are special made can go up to 25,000 Gauss or higher. And
So
what
yours
that
are how high?
what that depends on, in order to get them that high, you have to have a DC electrical source that's high enough when you unload that electrical force, it sets up a permeability in the magnet and aligns the domains in there in such a way that, like the sponge we were talking about that could absorb water, this magnet is breathing in energy from the background, but it's still not to where it can breathe it in 100%. It's breathing in a very small percent of the background, but it's still 25,000 Gauss, and multiply that by 100,000, and you'll see the equivalent of electrical equivalent of it. So when you're setting that domain thing, it takes a tremendous amount of electricity to do it.
Yours are 100 Gauss magnets, right?
Sir?
Yours are 100 Gauss magnets?
Well, each side, the side you're looking at is 100, and the other one on the other side is 100 Gauss, and between the two of them, the composite magnetic field, when they're reacting with each other, and 3/4 of an inch between it is not significant at all, because the magnetic field surrounding it is going to be as though it was just one magnet. And since that happens, the neutral area on the reverse spin of the electrons on one side is going one way, on the other side they're going the other way, and that sets up your north and south.
A group of us spent up until midnight debating this system.
Sir?
A group of us were up until midnight debating this device. We would like to build it. Like, what is the disc made out of, and so on and so forth. How do you polarize the magnets, and so on.
We'd like to duplicate your measurements.
So we could build
Okay, actually, if somebody showed me a photograph like I'm showing you, I could duplicate that thing down to the speck of dust. Well, the only way you'll ever find out is by doing. And chances are you may make some mistakes, but I make mistakes, and I probably made all the mistakes that anyone in here
to save ourselves
would
the time
make.
of having to go through all that.
Well, I'll tell you what on that. I have people who are in the process of setting up to manufacture these things on grand scale, and they're mostly overseas, but I have started talking to people here in the United States, and the basic way we handle that, if you're interested from a business standpoint, it's one thing. If you're an individual, it's something else. Now, if you're wanting to manufacture these things and sell them and that sort of thing, then what we do, we have a one-on-one visit, which you come to me and we sit down and we look at each other's needs, and we see whether we're compatible and that sort of thing. And then once that happens, then I will give you the plans on one of these things, and your part of the deal is that you have to build it and it has to work. And if you do that, then at that point we'll start talking about license to build it.
Now, Doc, for those of us who really don't care about making a single penny of profit, but we would
Well,
like to
at this
advance the state of
point, a lot of this you're going to have to figure out on your own, because it's not to my financial advantage to go beyond certain points. I've spent 10 years and hundreds of thousands of dollars into the millions getting to where I'm at. And somewhere along the line, I need to get some of that back if I'm going to survive. So,
That's what we paid for, Don.
Sir?
That's what we paid for. We
How much?
paid to come here.
Well, you have to feed in.
Energy independent.
Yes. There are a number of things we're going to be talking about. There's one in the book.
Time
We
in 8
came
minutes.
here to find
8
out
minutes.
how to become
Do what? 8
You got
minutes?
8 minutes.
independent.
Okay, let me say this. In the publications,
We paid for it.
in the
That's the way it was advertised.
you paid me paid for the book like $25, and I'm supposed to give you $2 million worth of information.
Well,
Am I that?
no, there are a lot of books out there that are just exactly that.
Well, I can tell you this. Why don't we discuss this after the meeting? You yourself are not going to sell 10 years of your life for a very small amount of money, are you? I doubt it.
If you're out to help the world,
Sir?
if you're out to help the earth,
Well, when I get this thing going properly, which it just about is, then at that point, I always say that you as an individual are very welcome to build your own. And I will supply you with enough information, if you're knowledgeable in what you're doing, that you will be able to duplicate it. So you'll have to do part of the equation yourself. There are too many people out there, and I just can't do everything for everyone. We actually have a number of other inventions which we haven't talked about, but since you want to stay on the energy thing, we'll go ahead and take questions. We only have about 8 minutes left, I understand. 5 minutes left. So if you have a question, this is a good time to ask it.
Can we see another one of your inventions?
Okay,
Can
well.
we see another one of
Ma'am?
your inventions?
Oh, I have a lot more photographs. If we can go through those uninterrupted, well, you'll be finding out a lot of the answers to your questions.
Thank you.
Okay, the flip side of what you're looking at there, let's see. Okay, this is the other side of what you're looking at. We'll call the side you're looking at as the top. This is the bottom of it. Okay, this is a little flea-powered motor, DC motor, that I'm using a dimmer switch out of a GMC truck, and with a 12-volt battery, and with this dimmer switch I'm controlling the speed of a magnetic shield that's rotating in the center there. I'll show you the magnetic shield in a little bit, but this is the bottom side, and I frequently set the thing so that that's down, even though it's made to sit like this. And the reason for that is it's more complicated on the bottom, and from an aesthetic standpoint, it's nicer to see the other side. But that's a flea watt motor there, powered motor there, and we're getting out about 1,000 volts for each one of those things. Now here's what if I take the top side off, the motor is underneath this thing, and the spindle from the motor is coming through, and that's a 13.5 inch disc. Yes, sir. Oh, excuse me. 13.5 inch disc, and we had talked earlier. I don't know whether everyone was here or not, but there are certain substances, chemical substances or elements or whatever you want to say, that are diamagnetic, which they're very much antimagnetic, and there's certain things that are paramagnetic. Now, it turns out that the things that are antimagnetic really don't interfere very much with the magnetic waves, because something you put between there is like a plate and a capacitor, so whatever's over here shows up over here. So using a strictly diamagnetic or antimagnetic substance won't work. So what you have to do is use another substance which has very high permeability to electrical flux, and what you do when the magnetic field hits the one that's very highly permeable to electrical flow and that sort of thing, well, the electrons are knocked out of their normal spin, and they change from a magnetic spin to an electrical spin, and they go out of the system at that point. Now, what you do, there's 2 or 3 things you do at that point. In the powder system, which is actually rubber cement sprayed on a sheet of plastic with a salt shaker full of something about this big that costs $200, sprinkled over that rubber cement that you sprayed there. Then you spray another layer of rubber cement and then sprinkle some more of that stuff. And once you get the level you want, in addition to what I'm putting on there, which is highly diamagnetic, there's another thing which intercepts. There has to be a highly permeable type thing which will absorb whatever is being deflected. So once it's deflected, then the other substance absorbs it, and that cancels it out. So you've canceled out a certain percentage of the magnetic field, which causes the flux difference between in the area where the coil is. The composite magnetic field varies. So when that varies by shorting part of it out, a certain percent of it. Now, these shielding materials vary from about 5% up to about 95% effectiveness. So, but in this case, you'd only need a very small amount. 5% of 200 Gauss would still leave you with 190 Gauss. So therefore, 10 times 100,000 would be your potential maximum electrical output on this thing, which you cannot do because the wires that you see there are good only up to about 1,000 volts or so and about 50 amps. So this system is set up for 1,000 volts at 50 amps, and there's 8 of those things, so that's 8 times 1,000 times 50 amps. So that's the system you're looking at right there. Now, this is what it looked like before I put the coils on it. These cylinders have the super magnets in there. It takes about $800 worth of super magnets to load this thing. So, and there's not much, unless you're going to buy them in large quantities, you're pretty well stuck with that. So you've got about $800 worth of super magnets. You've got about $100 worth of the wire that I was using there, which comes from Gateway Electronics. Denver, here in Denver is Gateway Electronics. In St. Louis, Missouri, Gateway Electronics, and I think in Los Angeles. And it's a multi-stranded wire. The more strands you have, the better the flux intercept and the better the quality of the electrical output. What is?
Copper wire, silver, gold.
The metal?
Yes.
And the wire? It's copper.
Thank you.
It's just pure plain copper, multi-stranded, and it's number 10. And it's a flexible DC for use with DC, but in this case we're taking advantage of the fact that DC is a little hard to manage. Well, that's why all the multi-stranded stuff, but it turns out that the more intercept of the magnetic flux lines you have, the more power you have, and that's why it's desirable to have as many little wires in there as possible, because
Teflon.
each one of them acts as a separate wire. Huh?
Is that Teflon insulation?
Well, Teflon will take you up well above 1,000. This is a kind of plastic, and it's rated at about 800 volts, which means it's tested at about 1,600, which means that if you run it at 1,000, you're probably within the safety margin. You've got a safety margin there. You never want to run it at its full capacity, and it will, based on the things that are going on, that number 10 wire is good for about 50 amps. That's 50 amps each. Each one of these pairs is a separate generator. So each unit would be 1,000 volts times 50 amps, And if you want to get alternating current on it, this one is the magnets are turned one way, and this one you're flipping them over the other way, and that sets up your sine wave deal if you take those two units together.
2-inch diameter, 1.5 diameter?
Those are 1.5 diameter. The magnet's 1.5 diameter. So the internal diameter of the thing, actually, I told you that the disc was 13.5 inches.
Yeah.
So if you take a little paper scale like that and lay it on it, you know the scale of everything else that's there.
I figured it's approximately 1.5.
Okay.
How do your wires come off the magnets and go to your terminal strips?
Well, they offset the disc that's in there. If you could see, we'll see on this one. Well, you can see it on this one. See where they're coming off. The disc is under a certain area. Well, you move out. I drill 4 holes, and that will take care of 2 sets of magnets. See, one of them will come like this and come back to this one here, and this one will come down and come on to this one. And you have to keep winding them in the same direction, because if you reverse it on the bottom one, you're canceling out.
Where do you take these off the terminal blocks to a set of capacitors?
Do what?
You take off the terminal blocks to a set of capacitors?
Okay, at the point where you've got electricity here, you've got up to this terminal block, and at that point it's not usable electricity. So what you have to do is you do some shaping of the energy source that you've got so that it will match whatever your transformers or load is going to be. And the way you do that, you have a capacitor bank which you feed it into, and you have it blocked off so that it can't kick back to the coils, so that it moves in only one direction. And once you're into that capacitor bank, then you're back to DC again, or pulsating DC. And when it leaves the capacitor bank, if your voltage level is down in a usable level, which it will be, say at 1,000 volts, then you feed it through the transformer, and it will be DC, but when it goes through the transformer itself, if you take your LCR meter and measure across the poles on the transformer, you get the capacitance and the inductance. So all things, even though they're an inductive device, will have capacitance and resistance and other things. And when you feed those onto a chart, which you'll find in American Relay Radio League Annual and a number of other places, if you know any 2 of the things that you have, you can project to the unknown. So what you want to end up with is say like 120 volts, which you can put a overflow thing which dumps the excess out, or you can keep it and say dump part of it out and use 440 volts at that stage at say 50 amps or 100 amps or whatever you want to. Actually, I have about 100 amps probably. Yes.
Do you have a physical model of this machine device built? Do you have a physical model of
Do you have a prototype?
Right.
This is a prototype, just like if you were going to build a Rolex watch, and you were going to take a patent on it.
Demonstrate how it works.
Sir?
How come you didn't bring that device here and demonstrate?
Because first of all, when you start moving these things around, you open up a bag of worms, and I have in the past brought devices, and the situation sort of got out of control, and the fact that I'm sharing this information with you, you can consider that my gift, because people do not normally give information out like this, because there are too many people out there that don't have the upstairs to come up with it themselves, but they're very clever at taking what somebody else has.
Yeah.
Yes.
Have you applied for a patent?
Yes.
Then you don't have a problem.
Sir?
You don't have a problem. You've already applied for a patent.
I have some doubts about patents because on the bottom line or next to it, it says they grant you the right to defend yourself. So how many tens of millions of dollars do you need to defend yourself?
And why'd you get a patent.
Corporations steal patents all the time. Is that what you're saying?
No, this is not for sale under any circumstances.
You missed the point. You said
It will be licensed.
when you apply for a patent,
Yes.
corporation lawyers have patent lawyers too.
Uh-huh. Okay, let me tell you this.
I
There
have a patent.
Uh-huh.
It, in 1974.
Yeah.
In the next 4 years, internationally, it was copied 4 times.
Yes. Okay, well, let me say this.
Never received $1 from that patent other than I manufactured the device
Yes.
for what. I'm not worried about the physics.
Okay.
You shouldn't be worried about the physics.
Okay, well, let me say this. I have been at patent inventions for more than 40 years, and one of the inventions that I had related to a radio transmitter type geophone, which is what you measure the, you put it out and you do certain things and you get reflections off the rock formations and they come back. Well, in that particular patent, the coprocessor, which is in your computer today, was in that patent which I did. And I did not gain by it, but the attorney which I had got with someone, and he has about a 40-story, real modern office building and a few other things, courtesy of my having used him. Now, he also, the Walt Disney Studios and some other people started using computers to make animated cartoons. This same gear shift mechanism, which is a coprocessor, that wasn't what I called it, but it's the same thing, is what they used for making the animated cartoons today, and the morphing and other things which you can do with your computer. So this same device which I invented, NASA used it on the moon. They shot some up there and put them across the surface of the moon, and they were able to tell what all the subsurface under the moon was. So this all happened more than 20 years ago, and so at that point I spent such a horrible amount of money on attorneys and other things, and basically ended up with nothing. And so you learn from these experiences, and when I finally decided to start filing inventions again, which they happen real fast in my head. I come up with them faster than I can write them down. But this time around, I have figured out the patent office pretty well, and I don't think this one will bounce even one time, because I have figured out their eccentricities and all the buttons, the right buttons to push and how to push them, and say exactly what I mean, but they don't. It means something else to them, which they agree with, but it also means what I meant.
Yeah, and you don't need it.
Yes. It seems as though we've probably run out of time, and we have a lot more photographs. This is some of the detail on the hookup.
Before you go, I'll make a couple quick
Sir?
announcements. Before you go, I need to make a couple quick announcements.
Okay. You want to borrow this
Yeah.
device?
Okay.
Okay. Based on what we've talked about here this afternoon, you should be able to duplicate what I've told you about for your own personal use. If you start manufacturing it or selling it commercially, if you're part of a commune or a religious unit or something like that, or some charitable type situation, I intend to provide those type of people with their own units at no cost at a certain time. But I need to build enough capital so that I can afford to do that. But all kinds of charitable type organizations, or any type of organization that is for the general betterment of humanity, even though they themselves may kill you because you think different than they do. You know how that goes. Okay, well, I think we've had